Okay, so as I said, we'll talk about dynamics, and they've got position, displacement, distance, and then you need to have the, distinction between all those three. I want you to think of a Cartesian plane. A Cartesian plane would be your X, Y, and Z axis. So if you think of an X, Y, Z axis, a position will be a point, just a dot in that X, Y plane. If it's 2, 3, 4, it means it's 2 units from the origin in the X direction, and then 3 units from the origin into the Y axis, and then 4 units from the origin into the Z axis. Now, how different is position from distance? The distance could be from any XYZ position to the other XYZ position in the Cartesian plane. In other words, you don't have to be from the origin all the time. When you talk about the distance, you need to say from this to there. You need to specify, is it from the origin or from a different point? Okay, so distance would be the path taken from position 1 to position 2, whereas position is just at one point with respect to the origin. Stop me if I'm losing you guys, because I'm not going to be writing a lot today. Then we talk about the displacement. The displacement is the shortest distance between 2 positions. The distance will be the actual steps taken, meaning it takes into account the path that you took. Whereas the displacement, it is just the shortest path, a straight line from where you started to where you ended. Here are some examples. If a particle moves in the X direction only now, from X equal to 5 meters to X equal to 12 meters, what would be its distance? The change in position, which is your distance, and it's the same as your displacement. The minute you see the arrow on top of a symbol S there, or any symbol, it means it's a vector, right? So it will be final minus initial, final 12 minus initial 5, and that's why you get 7 meters, and it's positive. So it means it is to the positive x-axis. And then from position x1 equal to 5 meters to position x2 equal to 1 meters, you were 5 meters ahead, now you're coming backwards, isn't it? Final minus initial, 1 minus 5, and then you get minus 4 meters. And it is in a negative direction, meaning you are reversing, okay? So it means you basically took 4 steps backwards, or 4 meters in the opposite direction. In the first one, the distance will be the same because it's a straight line, 7 meters. The second one, from 5 to 1, the distance is not going to be minus 4. Distance is not a vector. So it's just going to be 4 meters. So if I ask you what is the distance between x equal to 1 to x equal to 5, you basically just say 4. There's no need to put a negative sign. If you go from x equal to 5, you go to x equal to 200, it means you've gone 195 meters in the positive direction. And now you are at 200 meters. You need to go back to 5 meters. So who can tell me what will be the distance traveled?
210.
It's going to be 195 to going forward times 2, meaning going backwards. So it's going to be 390 meters. So that will be your distance traveled.
Oh, I don't understand. Say, how will it be 390?
Okay.
But I also don't understand.
You don't get that one. You go from here, you come back to 5. That's what they are saying. Right?
Yes.
How many meters?
Yes. In total, there are
390 meters.
390.
90
But
years.
what is your displacement?
0.
0.
0. You start at the, you end. Okay? And this is in the XY plane. We're just using the X direction. Any question, or can I raise?
Sir, I have a question.
Yes, ma'am.
Yes. When we talk, like, I just want to understand what you just said, Nick. So, position is the point from 0 to a certain point. No, it's a point in the Cartesian plane, right?
Yes, just one point.
Okay, and then distance is the space or distance between 0 to that position.
So
yes.
Distance must take into account two positions. The distance from megacity to Cape Town, right? But if you are saying the position, if I say, where are you? You'll say, I'm in Mutuseng. I won't say from where. So a position is basically a location in space. So displacement is the shortest distance between 2 points. Distance is the actual path taken between 2 points. Are we together?
Yes, sir.
So then we get what you refer to as velocity and speed. First, let's talk about average speed, the total distance over the total time. Distance, not the displacement. Instantaneous simply means at that instant in time, meaning one value that was taken at that point in time. For average, we take the total distance. For instantaneous, we look at the point in time. How do we calculate the instantaneous speed? I'm going to draw a graph here of displacement time. And let's say the graph is something like that. Meaning you started at the high displacement and then you come into somewhere there, which is maybe say 10. Maybe this is 100. And this is maybe 20. What would be your speed there when the time is that? At that point in time, what was your speed? You take what is referred to as the slope of the curve at that point. Let's put it in practice now. If a particle moves from position x1, which is equal to 5, and then it goes to position x2, which is equal to 12, and then to position x3, which is equal to 4 in 2 seconds, what would be its average speed? From 5 to 12, what is the distance?
7 meters.
7 meters. And then from 12 to 4, what will be the other distance going back?
8 meters.
8 meters. So the total distance will be 7 plus 8 divided by 2 seconds. So that is basically 7.5 meters per second. But now let's look at the average velocity. If you're considering the velocity, not the speed, then you're going to say final minus initial, which is 12 minus 5. What is it? 7, right? And then you are at 12. Now you need to go to 4. So it will be 4 minus 12, which is the final. Final was 4, right? Minus where you're coming from, which is 12. And when you solve this, you get 0.5. And who can tell me, why is it negative?
We're going to a negative direction.
We're going to an opposite direction.
So that's your velocity, not speed. We'll keep acceleration as a vector, not as a scalar, right?
Yes.
Instantaneous acceleration is the slope of a velocity time graph, just like instantaneous velocity is the slope of displacement time graph. We want to find the velocity of a particle whose xt graph is shown. So it started here and it ended there. You have to ask yourself, are we talking instantaneous or are you talking average? If it's average, you are just going to say, let's say this is 100 and say this is 20. The average will just be final displacement, which is 100, minus initial, which is 20. So it means you've covered 80. So it's 80 divided by the time taken. At this point, at one point, we say instantaneous. So to calculate the instantaneous velocity there, that will be the slope of the curve at that point. X dot is the same as velocity because you've differentiated X. Now, what about V dot? V dot is the V dt. So the V dt is V dot. And what is that? That is going to be acceleration. Acceleration means the V dt, which means you differentiate in twice. First, you differentiate the displacement, and then secondly, you differentiate the velocity. So that's why you get d squared. Let me show you what I mean. Here's an expression for displacement because it's in meters. And the question is, find the acceleration of the object. So you take the first derivative. And remember, because it's x, when you do the x dt, you're going to get v. The first differentiation will give you velocity. The second one will give you acceleration. So it's 1 times 4, which is 4. T to the power 1 minus 1. That's t to the power 0. And what is t to the power 0? That's basically just 1. So the answer for this whole thing will just be 4. 1 times 4 times 1. And then here you are just going to say 2 times 2 and 2 minus 1. So that will be 4t to the power 1. So this is an expression for what? For velocity. But we are looking for the acceleration, not the velocity.
So say, this is like every time we calculate instantaneous acceleration, we have to write the whole formula as it is.
Whether or not you are able to get straight to the answer or take the long step, for me, it doesn't matter. You don't have to write everything. You can basically just say 4t, the differentiation with respect to t will just be 4. 2t squared will just be 4t. That's it.
Yeah, yes.
All right, and then you differentiate this expression now with respect to t again so that you can get acceleration. So it's x dot dot, which is now acceleration. X dot was velocity. Here there's no t, right? So this becomes 0. So you are left with this function only, that is t. T to the power 1, so 1 minus 1 becomes t to the power 0, which is 1. 4 times 1. So you basically then end up with 4 as your answer for acceleration. These are the equations that you know, the equations of motion, right? There's a limitation to these equations. And what is the limitation? Who can tell me when can we use these equations?
Linear.
Linear. So only when it's in a straight line.
Linear motion.
Yeah, so they have to.
Or maybe if our acceleration is constant.
When acceleration is constant, yes, because acceleration can only be constant if there's a linear motion. So these equations are only applicable in straight line motion. This is an xt graph, and I might ask you then to describe the motion, and I think you've done this also in metric. At t equal to 0, the object was at displacement of -5 with respect to the origin. And then when time was 3 seconds, it was at 0. And then when t equal to 4, it went to 2 meters in the positive direction. So basically this object or this porcupine is going from there up like that. It starts there and it ends there. But because time is moving this way, that's why you see your graph being curvy like that. Now, what was the instantaneous speed of the porcupine at 3 seconds?
0. Yeah.
Okay,
Yes.
why 0?
Because at that point of 3 seconds, the porcupine was stationary.
I don't think it was stationary, but
At 3 seconds.
so
Because
can I
its position is
say what
0.
I think?
Okay. Yeah, okay. Ladies first.
At 3 seconds, it's changing direction.
At 3 seconds, it's changing direction. All right?
Yes.
Sir,
Yeah.
I think at 3 seconds, it went back to its initial point of movement. I don't know if I'm making sense.
Yeah, I hear you, but all of you seem to be wrong this time. One last.
Sir,
Sir, is it not changing direction?
sir,
Sir, I
Isn't
think
it-
it's because at 3 seconds the displacement is 0.
thank you.
The displacement is 0 with respect to who?
With respect to the origin, sir.
Okay, means you are here, okay? You are there. So where's the porcupine at t equal to 0? There,
Yeah,
right? When t equal to 3, where's the porcupine? There. When t equal to 4, where is it? There. Now try again. What is the velocity of the porcupine at t equal to 3?
True. 0, sir.
There's no displacement between you and the porcupine at t equal to 3. It is right next to you, passing you, but it doesn't mean it's stationary.